Hello, this is Manikanta from BVRT College, studying second year CSE. Now I'm going to explain the total order set, which comes under sets and relationships. Set is what set is a collection of objects which is similar or different. Like it's a collection of different integers or any other like something. Or this come the total order set comes under and the set and its relations. Like let's get into deep that what is total order set. Mm, here we are. A total order set is also known as a totally ordered set or simply a total order set. It refers to a set equipped with a binary relation that satisfies three properties. Um, we can say a set that is a total order set by confirming that the equation satisfies or set satisfies the properties. They are reflexivity, antisymmetricity, and transitivity. Uh, Here are the three. Reflexivity, let's know about it. For every element A in the set, A is related to itself. That means in every set, uh, the particular A in the set, that A is related to itself. In mathematical terms, it is expressed as shown below. A less than or equal to A. That means it is related to itself. The total order set is a comparable set, which comes under if set A and B, the set should be comparable. Like A should be comparable to B. Antisymmetry. If A is related to B and B is related to A, then A and must be in the same element. Like if there are sets and A should be related to B and B should also be related to A, then A and must be consist of same element. Like mathematically, it's written as A less than or equal to B and B less than or equal to B. That is equals to A equal to B. Like anti-symmetric is the one of the property that which says a set is totally order set or not. Now let's go to the third property. It is transitivity. Let's know about it. If A is related to B and B is related to C, and A should must be related to C. Like if we take A, B, C are three elements in a set. A related to B, then B is related to C. Obviously, the A should be related to C. The symbols for it are as given there. A less than or equal to B and B less than or equal to A, then A less than or equal to C. Now let's go to the next slide. Poset. A total order set is also a poset. A relation is an partially ordered set that is called poset if and only if the relation is reflexive, antisymmetric, and transitive. Every total order set is a poset, but every poset is not a totally ordered set. It's because it does not satisfy certain properties. So it is said that every poset is a totally ordered set, but every totally ordered set is not a poset. Mm, the poset is partially ordered set. It should satisfy the three relations: reflexive, antisymmetric, and transitive. Now reflexivity. A relation R on a set A is called reflexive relation if A comma A belongs to R and A belongs to A. Like that is that R for all A belongs to A, where R is a subset of AXA, the Cartesian product of set A with itself. Like Um, let's see here. A relation of R on set A is known as reflexive. Means A should be related to R. So it is property which satisfies the equation. It comes under totally ordered set. And let's see the next one. Antisymmetry. As per the set theory, the relation R gets considered as antisymmetric on a set A if R x r y and y r x holds, then x is equals to y. For example, in a set there is x and y, and if x comma y and then y comma x holds, given that x is equals to y, you can also say that relation is antisymmetric with x comma y does not belongs to R and y comma x does not belongs to R. When x comma y not equal, x not equal to y. Let's see this deeply. If x and y and x belongs to the same set, then it gives x is equals to y. If that does not belongs to R, then x not equal to y. So this comes under antisymmetric. As this comes under set theory, the relation R gets considered as antisymmetric on set A. Transitivity. A property is called transitive property if x comma y and z are three quantities, if x is related to y by some rule and y is related to z by some rule, then we can say that x is related to z by the same rule. The transitive property can be used for relating the quantities if we have three or more quantities. Like let's take example of A, B, C if there are three quantities. If anyhow A is related to B and then B is related to C, then A should be related to C in the same rule because all they should be connected in the transitive property. Like A should connect it to B and B should connect it to C. Then automatically A will be connected to C. So by the same rule, this comes under transitive property. Let's take an example of 1, 2, 3. 1 should be with 2 and 2 should be with automatically 1 should be with 3. This comes under transitive property. The transitive property for used for relating the quantities if you have 3 or more than 3 quantities. Uh, like symmetric and other are used for 2 quantities, but transitivity is used for 3 quantities. So the next one, totally ordered set. If the given is a poset and every two elements of S are comparable. So as I firstly said, totally ordered set is a comparable set. Like the elements in the set should be comparable. Like let's take an example of A comma B that should be comparable. If they are not comparable, it does not come under totally ordered set. If S comma less than or equal to is a set and every two elements of S are comparable, then S is called totally ordered set or linear ordered. Like we have discussed, totally ordered set is also called linearly set. A totally ordered set is also called a chain, and it is also called as comparable set because the elements should be comparable to each other in every set. If it does not comparable, it is not a mm, totally ordered set. Let's take an example. Uh, there is Alexa and Siri. They both are comes under same. They are comparable. Like if we take Alexa and a pen, they are not comparable. So this the elements in the set should be comparable. Then only it is called as a totally ordered set. Like let's take example. The poset set is totally ordered because either A less than the elements in Z, A less than or equal to B or B less than or equal when A and B are integers. Let's see these are comparable so that It is called as totally ordered. Let's take the second example. Suppose that z plus z is set of integers is not totally ordered because it contains elements that are incomparable such as 5 and 10. Let's see. The given poset is not totally ordered because it contains elements which are incomparable. As I said, the totally ordered set is comparable set because the elements should be comparable. So it is incomparable, so it is not a totally ordered set. So let's mm, so this is all about the totally ordered set. Hope all of you got some information about it. This is helpful for the sets and relations. So thank you.